let's look at how we can solve this exponential equation. As with lots of other types of equations, our first step is going to be to isolate the portion of our equation that has our variable that we're solving for. So to isolate my exponential expression, I'm going to divide both sides of the equation by 5. So this gives us the equation 1.3 to the power of x is equal to 10 divided by 5, so it's equal to 2. We're going to look at two different strategies of ways that we can solve this equation. So strategy number 1 is to use properties of logarithms in order to rewrite this. So if we take our 1.3 to the power of x equal to 2, we can take a log of both sides of our equation. So when solving an equation, as long as we apply the same operation on both sides of our equal sign, we won't have changed our solution. So we can pick a log of any base. So I'm going to choose one that's easy to type into our calculator, either a natural log or a log base 10. So let's look at using a natural log. So I'm going to take the natural log of 1.3 to the power of x and the natural log of 2. So whatever I do on the left-hand side, we always do the same thing on the right-hand side. So our properties of logs, our exponent property says anytime that you have an exponent inside of a log expression, we can move it out in front as a coefficient. So I can rewrite this as x times the natural log of 1.3 is equal to the natural log of 2. So now, solving for x, since it's x times the natural log of 1.3, I can divide both sides of my equation by the natural log of 1.3. So this gives me that x is equal to the natural log of 2 divided by the natural log of 1.3. If I put this into my calculator, I find that x is approximately 2.6419. So that first fraction would be my exact solution in terms of logs, and the second is a decimal approximation rounded to 4 decimal places. So let's look at a second strategy. So if we have 1.3 to the power of x is equal to 2, we can also use the definition of logs to help us to rewrite this. So when we talk about the definition, we're saying that if you have log base a of b is equal to c, that's equivalent to rewriting a to the power of c is equal to b. So this is the same as having a to the power of c is equal to b. So these are equivalent expressions using the inverse relationship between a log and an exponential equation. So we currently have an exponential equation. I'm going to turn that back into a log equation using the definition. So since the base in the exponential equation is 1.3, I'm going to take a log base 1.3 of 2, and that's going to be equal to x. So on some of your calculators, you're able to type in an expression like log base 1.3 of 2 directly into your calculator. If you have a TI-83 or a TI-84, it may be in the math menu. So if you hit your math button and then scroll all the way to the end of the list, you may see a log base button. Not all of the graphing calculators have that option. It just depends on the age of your calculator. If you don't have a calculator that has that log base option, then we need to use our change of base property. So this tells us that we can rewrite a log of any base into a log of a base of our choosing. So the change of base property says take a log of a base of your choice. So you could either pick a base 10 or a natural log with a base of e, since that's what's built into our calculator, of the original argument, the thing that was originally on the inside, divided by a log of that same base that you chose of the original base. So this is what it would look like if we had chosen base 10. If you chose base e, you could also write it as natural log of 2 all over the natural log of 1.3. And notice that's the same thing that we got when we used strategy number 1. If we put either of these expressions into our calculator, we'll get 2.6419. So this gives us a couple different ways that we can solve this equation, 5 times 1.3 to the power of x equals 10, either starting out with our properties of logs using the exponent property or using our definition based on the inverse relationship.